Now we're going to be solving by factoring. There's a few different factoring methods that we're going to be looking at. For this first one right here, we're going to use one similar to the difference of squares. Whenever we have an even exponent, what we can do is we can find the square root of each one if there's two terms. And that gives us x squared minus 9 and x squared plus 9. And both of these are equal to 0. We know that this is a special factoring pattern again, so we keep on going, x minus 3 and x plus 3. And we keep the x squared plus 9 is equal to 0. Now, zero property states that anything times 0 is always 0. What that means is that this binomial gives us an answer of 0. This binomial gives us an answer of 0. And this binomial gives us an answer of 0. So it looks similar to this. X minus 3 equals 0. X plus 3 equals 0. And x squared plus 9 equals 0. Now for this first one, we add the 3. So our answer would be 3. Here we subtract the 3. So our answer is negative 3. Here it's a little tricky because when we subtract the 9, we get negative 9. And when we take the square root, remember we have two roots. We have a positive and a negative. The positive would be positive 3i because the square root of a negative is I, and the negative would be minus 3i. So that gives us 4 different answers. Notice that we're getting real answers and imaginary answers. Now, looking at letter B, we notice that they have a 5x in common. So we factor out a 5x. That gives us x to the 4th minus 16 equals 0. Well, we see a special factoring pattern. So we factor the x to the 4th minus 16, and that becomes x squared minus 4 and x squared plus 4. This continues to be factorable, so we factor the x squared minus 4 into x minus 2 and x plus 2. And the x squared plus 4 cannot factor, so we leave it. Similar to the last one, what we're doing is we're setting each of these equal to 0. We're going to try to do this in our head. What would give us a 0 here would just be 0, and all monomials are always 0. For the binomial, we would add 2. So if we were to plug in a 2, that would give us 0. If we were to plug in a negative 2, that would give us a 0. This is going to be similar to the last one. If we took the x squared, subtracted the 4, and then took the square root, remember there's two roots. There is a positive and there is a negative. Notice that there are 5 answers. 1, 2, 3, 4, and 5. Notice that this is degree 5. This one has 4 zeros. Notice that it's degree 4. Letter C is similar to what we did last time. It's a cubic, so we're going to use the special factoring pattern where we write it as cubes. And we have x minus 2 and x squared plus 2x plus 4 is equal to 0. Now, we know that this one gives us an answer of 2, but this one is not factorable. So that means that what we need to do is use the quadratic formula. So we're going to go x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. That gives us negative 2 plus or minus the square root of 4 minus 16 over 2. 4 minus 16 is negative 12. And negative 12 simplifies to plus or minus 2i square root of 3. Now, all of these have 2, so when we divide it by 2, what we get is x is equal to negative 1 plus or minus I square root of 3. Now, we have to remember the 2 up at the top. That would be our other answer. Notice that we have 3 answers. We have the 2, we have the negative 1 plus I rad 3 and the negative 1 minus I rad 3. Notice it's degree 3. So looking at letter D, we see it's a quartic. We see that it's a special factoring pattern because we could find the square root of each one. So that would be x squared minus 4 and x squared plus 4. Similar to what we've done before, this right here breaks down into x minus 2 and x plus 2. And the x squared minus 4 we can't factor anymore. Now we have to find our zeros, 2, negative 2, and the x squared plus 4 we know is 2i and negative 2i. Now letter E, notice that they both have a 2x in common, so we factor out a 2x. We get x to the 4th minus 625. If we were to take the square root of each one, it would give us the x squared minus 25 and x squared plus 25 is equal to 0. Now we factor this again and we get x minus 5 and x plus 5. We're going to find all our zeros. Monomials give us 0. Opposite would be 5, negative 5. And we know that in the back of our mind, we move the 25 over and then take the square root, and we get 5i and negative 5i. Notice that we have 5 answers. It's degree 5. Now, if we're looking at this next one, we factor out a 2x, and that gives us x cubed plus 27. We see that these are cubes. It would be x cubed and 3 cubed. So when we use our special factoring pattern for the sum of cubes, we get x plus 3 and x squared minus 3x plus 9. I'm going to use the quadratic formula on my trinomial, and I get 3 plus or minus the square root, negative 3 squared minus 4 times 1 times 9, all over 2 times a, which is 1. That gives me x equals 3 plus or minus the square root, 9 minus 36, all over 2. X equals 3 plus or minus the square root of negative 27 over 2. And that right there, negative 27, simplifies to 3 plus or minus 3i square root of 3 over 2. Now that right there is 2 of our answers, but we have 2 more. What we have is we have our 2x, which gives us an answer of 0, and we have the x plus 3, which gives us an answer of negative 3. Those right there give us 4 answers. Notice it's a quartic.